Hello, 5th graders. Welcome to lesson 11.6, Numerical Sequences. Let's get started. Today's objective is I can determine the rule in a numerical sequence by completing and continuing the pattern with 100% accuracy in multiple attempts. Please pause to write the I can and by statement in your digital math notebook now. All right, 5th graders, today we're going to talk about numerical patterns and their rules. This relates to graphing because we're going to talk about x and y values and how x relates to y. So a numerical pattern shows that a rule is being used on an ordered set of numbers. That means that we are doing a rule, adding, subtracting, multiplying, dividing, to a number in an order that we call a pattern. We can see this in a table where we call x the input and we call y the output. So it's like we put in the number x, something happens in the middle, and then we get out the number y. In this middle, we call this maybe the magic column. That would be like we add 2 or we multiply by 5 or whatever our rule tells us to do. This is where we put our rule. If numbers increase, then from x to y, so if we put in x, and then we get a bigger number for y. When we know, then our rule is either going to add or multiply. If, however, our numbers decrease, we put in x and then it gets smaller, that means that we're either going to subtract or divide. Numbers in our table do not have to be in order. So that means I can put in a number and it could get bigger or smaller. That doesn't mean that I have to go 1, 2, 3, but it does mean that x and y always stick together. We want to use at least 4 pairs to find a pattern. So we want to look at not just the first column, but the second and the third, and make sure that our pattern is continuing throughout. Let's try some patterns together. 50. All right, guys, this pattern is in your digital math notebook. We have a rule that we need to follow and some boxes we need to fill in. Our rule is we're going to multiply, that x is a multiply, by 4. So let's see, if I put in the number 5 and I multiply it by 4, I would get the number 20. 4 times 5 is 20. Now let's see if we can go to the next one. Now this one's a little bit tricky because I have to think about what times 4 was 32. I have to undo the multiply or divide. So I know that 8 times 4 is 32. Now we have to go backwards again in this next one, but I know that 4 times 11 is 44. So I'm undoing the multiply by 4 to find the missing numbers. Now this time I don't have to undo, this time I have to multiply. So if I have 14 times 4, let's see what goes in that blank. 4 times 4 is 16. 4 times 1 is 4, plus 1 is 5. So that would be 6. All right, let's fill in one more. 17 times 4. 4 times 7 is 28. And 4 times 1 is 4, plus 2 is 6. So that would be 68. So in order to be able to continue a pattern, we follow the rule. Now, if we have a pattern that's already established, we need to find the rule. When we find the rule, we want to look at, remember, at least 4 data points and see if we can figure out how they're related to each other. So from 64 to 8, I know that my number decreased. It also looks like from 48 to 6, from 40 to 50, all of these numbers are decreasing. So that either means I can subtract or I can divide. So let's see if there's a pattern that goes together. So I have 64 minus 8? No. How about 64 divided by 8? Let's see if it checks out. 8 times 8 is 64, or 64 divided by 8. 64 divided by 8. Let's try the next one. 6 times 8 is 48, or 48 divided by 8. That works. The next one, 5 times 8 is 40, or 40 divided by 8 is 5. So I'm checking to make sure that I don't get 3, 4 down and all of a sudden my rule doesn't work anymore. Let's try some more patterns together. All right, in this, we have an input-output table where they've given this the input, but not the output. It says, the rule for an input-output table is A equals, A is the output, A is what we're going to get out, W plus 7. W is our input. That means what we're going to add. So when W is 1, then we do 1 plus 7. So 1 plus 7 would give me 8. So when W is 1, then A is 8. I put in 1, I get out 8. When W is 2, 2 plus 7 is 9. So when I put in 2, I get out 9. When W is 3, 3 plus 7 is 10. The output is 10. When W is 4, 4 plus 7 is 11. So here's our question. What is the output if the input is 3? So if we put in 3, we added 7, we got out the number 10. Make sure that this is in your digital and math notebook. Type in the boxes and move the circle to the correct answer. Great job, 5th graders. Make sure that your digital math notebook is complete before you do your exit slip. Great job.